A body of mass 2 kilogram is released from a point 100 meter above the ground. Calculate its kinetic energy 80 meter from the point of release. Now, there are two methods you can apply in solving this problem. You can use the equation of motion to find the velocity at the 80 meter point. That is one method of doing it. Another method of doing it is to use the conservation law of mechanical energy. So I want us to use the conservation law of mechanical energy so that we can learn that method. So in doing that, I would like to have a sketch first of this. So let me say this is the top where the object is released from. And then this is the bottom. So the object is released from this top, which is, let's say, 100 meter. So let me say from here to here is 100 meter. So that is the point of release. And we are told that when it has fallen down up to the point of 80 meter, what is its kinetic energy? That means it needs how many more meter to get to the ground? It needs 20 more meter to get to the ground. Now, what we need to do here is to remember this important point that KE, that is kinetic energy, plus potential energy is equal to a constant. Is a constant value. So at every point from the very top here to the bottom, at every point in time, this is very, very true, provided energy is not lost, that the total kinetic energy plus the potential energy is always a constant value. So don't forget that the formula for potential energy is mgh. Potential energy, don't forget, is equal to mgh. So from there now, we can look at this top point. At this top, the potential energy is equal to 2, which is the mass. We're using this formula now. 2, which is the mass, multiplied by g, which is 10, multiplied by the height, which is 100. So the height at this top is 100. So that will give us how many? That will give us 2000 joules. So at this top point, the potential energy is 2000 joules. But don't also forget that at this top point, the kinetic energy will be what? Will be equal to 0. Hope you agree with me on that. Because at the top, it is not yet moving. So the kinetic energy is 0. Kinetic energy starts immediately it starts moving downward. But at the top, when it is not yet moving, the kinetic energy is 0, but the potential energy is 2000. Then now, when it gets to this point, so this level now, when it gets to this level, its height above the ground is only 20. Don't forget, that is 80 plus 20 will give us the total height, 100. So at this level, its height above the ground is 20. So at this point, I can also calculate the potential energy as equal to the mass, which is 2, multiplied by g, which is 10, and multiplied by h. Don't forget, h is always the height above the ground. So at this point, its height above the ground is only 20 meters. So times 20. So at this level, I'll say the potential energy is 400. That is 200 times 2, which is 400 joules. Now with this, we are almost there. Now let's apply the basic theory there. PE plus KE at any point is a constant, value. At the top, the PE is 2000, right? We have calculated it. You can see the PE is 2000 at the top. Plus the KE at the top is 0. So plus 0. So 2000 plus 0 will give us a constant value, which is 2000. So 2000 plus 0 is 2000. Now, at this level, at the level that we're looking at now, the KE, or the potential energy at the level that we're looking at, is 400. That is 400. Plus the kinetic energy at that level, and that is what we are asked to calculate. The kinetic energy at that level is what we are calculating. And everything should be equal to the constant value, 2000. So from there now, we can now move on to say KE is equal to 2000. When this plus 400 comes to that, it becomes minus 400. So 2000 minus 400 will give us 1600 joules. So at this level here that we have just analyzed now, at this level, the potential energy becomes only 400, while the kinetic energy has increased to 1600, so that their total energy at any point will always be this 2000 as a constant value. So the kinetic energy at that 80-meter level is 1600 joules, and this is the final answer. But let me just try to re-emphasize one important point so that I'll ask you to try it out and let me know your answer in the comment section. You can calculate by using equation of motion. You can calculate the velocity at the 80-meter level. That is what you can calculate. You can use the equation of motion. And the right equation of motion to use is v square is equal to u square plus 2gh. You can use this equation of motion to find the final velocity at this 80-meter height. Now, after getting the final velocity, then you can now use the kinetic energy is equal to half mv squared. By the time you use this formula, it will exactly give you this final answer of 1600 joules. Please try it in the comment section and just type in the same. If you got the same answer of 1600, just type the same in the comment section and let me know. I hope you enjoyed this video. Please don't forget to like, share, and join for more videos like this. Thank you for watching.